What are IC and ICP? IC stands for Internet Computer, which is a high-speed blockchain network specifically designed for decentralized applications. ICP refers to the Internet Computer Protocol, and it is also the name of the token. The architecture of IC is unique. Nodes in various data centers are virtualized into replica through the node software ICOS and then randomly select some replicas to form a subnet. A subnet consists of nodes from multiple data centers. Each node establishes a TCP session with IPv6 and connects to NNS nodes and other nodes within the same subnet. NNS, Network Nervous System, is an embedded governance system in IC, which is a DAO. Anyone holding ICP can vote on proposals on NNS. Bitcoin network nodes can join anytime and anywhere, but this brings the problem of slow transaction confirmation speed. Consortium chains first determine a few nodes in the network, and then these fixed nodes reach a consensus, making the speed very fast. IC combines the advantages of both, forming subnets with a few fixed nodes like a consortium chain, and the speed of reaching consensus between nodes, replicas, is very fast. It is controlled by a DAO, NNS, which controls the subnets and nodes, replicas, a win-win situation. IC integrates a DAO at the bottom of the blockchain protocol, the DAO-controlled network. This DAO controls each subnet, configures the network topology, creates subnet public keys, and upgrades the protocol version of replicas. Therefore, all NNS decisions are determined by community members, and the voting weight of community members is determined by the number of IC native governance tokens they pledge in NNS. If the proposal is approved by everyone's vote, the canister in NNS will automatically execute the decision. For example, if a proposal to change the network topology is approved, NNS will automatically update the registry canister with the new configuration. NNS is also a decentralized governance system that helps the IC network achieve self-evolution. The purpose of NNS is to manage the Internet Computer Network in an open, decentralized, and secure manner. It is the system subnet of IC, controlling IC's subnets. It can also upgrade node protocols, adjust the exchange rate between gas token cycle and ICP. And in extreme cases, it can even freeze malicious canisters to protect the network. Replicas can be understood as virtual nodes virtualized within the subnet. IC is composed of many subnets with no concept of a parent network, main chain, side chain, or beacon chain. Each subnet is equal, except for NNS. Each subnet operates independently, reaching consensus and producing blocks within the subnet. There is no global consensus like Bitcoin, and different subnets synchronize and produce blocks in parallel. It can be understood that each subnet is a blockchain, and many chains together form IC. Cross-subnet communication is solved at the IC base layer by chain key. Developers and users do not need to worry about which subnet the smart contract is deployed in or how to communicate across subnets. Chain key is the core technology behind the Internet Computer, solving the problem of communication between IC subnets. Chain key enables each subnet to generate its unique subnet public key, subnet key, based on the root key. This is the foundation of IC's unlimited scalability. Each subnet has a public key of only 48 KB in size. Anyone can verify whether the received message is sent from the IC network and whether it has been tampered with. Various IoT devices and other blockchains can also verify information from IC. In contrast, when verifying traditional blockchains like HED, devices need to synchronize hundreds of GBs of signature data because each block is signed by different nodes. In IC, all replicas sign a block together. Therefore, devices only need to save a unique 48 KB public key to verify each block. Subnets can be dynamically added, removed, or merged according to the network's resource usage. There is no upper limit to the number of subnets, so theoretically, it supports unlimited expansion by adding new subnets around the world. But who decides the splitting and recombination of the subnets? NNS, Network Nervous System, NNS is a special subnet, and like other subnets, it is composed of several nodes. NNS can manage other subnets. However, NNS subnets have more nodes, so their security is naturally higher than other subnets. Operations such as data centers becoming nodes, a specific node joining a subnet, the composition of a subnet, creating a new subnet with a few nodes, and splitting a subnet into several subnets all require NNS permission. The architecture of many subnets allows IC to scale infinitely. The core part of the IC protocol is divided into 4 layers, running on nodes within each subnet. The IC core protocol has a total of 4 layers, and each replica has this 4-layer structure. From bottom to top, they are the P2P layer, consensus layer, message routing layer, and execution layer. P2P layer collects and sends messages from users, other replicas within the subnet, and other subnets. Ensures messages can be delivered to all nodes in the subnet to guarantee security, reliability, and resilience. Consensus layer reaches consensus on the order of message processing. Then, these blocks are passed to the message routing layer. Message routing layer forwards messages. After the consensus layer finalizes the blocks, the corresponding payload is passed to the message routing layer. The message routing layer inputs the execution layer. Execution layer, where canisters run. The execution layer updates the corresponding canister state in the replicated state machine, completes smart contract computation tasks, and hands the output over to the message routing layer for processing. IC simplifies Ethereum dApp development and traditional web development. Developing dApps does not require third-party wallets or developers to consider middleware, load balancing, firewalls, etc., as these are all handled by the IC protocol layer. Canister is a lightweight WASM WebAssembly container. Canister is IC's smart contract, which can store code logic, data state, and front-end resources. Developers do not need to worry about underlying communication. They just need to deploy code to the canister, and users can access the application directly through a URL. In theory, all languages that can be compiled into WASM byte code can be used to write IC smart contracts. Motoko, Rust, C, C++, Java, Go, JavaScript, etc. Thus, both front-end and back-end can be compiled into WASM and installed into containers for on-chain deployment. The essence of blockchain technology is to reduce the barriers and costs of value exchange between global individual economic agents and machines to almost zero. However, Ethereum currently cannot achieve this vision and ultimately relies on the maturity and popularity of various infrastructures. Imagine what it would look like if blockchain technology successfully addressed scalability, security, and usability issues. Bitcoin is a decentralized ledger. Ethereum created a decentralized computer. Polkadot achieves composability and scalability of blockchains. The Internet computer is building a highly scalable, composable, decentralized cloud, just like the difference between an early distributed system and a cloud computing system. Traditional distributed systems required a significant amount of manpower and resources for development and maintenance to scale, whereas cloud computing systems can automatically scale elastically, an advantage that traditional distributed systems do not have. As a result, many companies' distributed businesses have chosen to move to the cloud. The key to scalability lies in near-zero marginal costs. Polkadot's scalability is built on the development of software engineers, while IC's scalability is automatically accomplished at the underlying level. This reduces the development costs for application teams working on IC. To create a highly scalable, high-performance public chain, first, pay attention to scalability and performance in planning. Design and layout in all aspects should focus on achieving scalability and TPS as quickly as possible. Second, have confidence and strength. Stick to your own path until the day the ecosystem explodes. In the meantime, endure the pressure from competitors in the short term, withstand the pressure of cash flow for a long time, and ignore the misunderstanding of the secular world. Focus on the development of underlying infrastructure until various creative applications emerge, increasing the number of ecosystem participants. The increase in numbers leads to the emergence of new ideas and applications. This creates a positive feedback loop, making the ecosystem spontaneously more prosperous and complex. I believe the keywords for the future of blockchain are zero latency, zero marginal cost, an open ecosystem, and the huge scale effects, extremely low unit costs, and richly complex ecology it brings. The industrial upheaval brought about by technological revolution is sudden for most ordinary people. But behind this suddenness are years, even decades, of gradual evolution. Once a few key parameters that impact the industry structure cross the critical point and the ecosystem enters a period of prosperity, the transformation is extremely rapid.